Audio Jungle. Audio Jungle.
Fine. So next is what? Turning flight. Okay. So in the turning flight, first of all, what is the turning flight? So see, turning flight is like basically turning towards right or left. Huh? So if you write turning flight, sometimes called coordinated flight, okay, or coordinated turning flight, or coordinated turn, or level turn also. Okay, sometimes it is also called banked turn. So I will give a different name so that it should be clear. Okay, and what is the condition for the coordinated turn? That also very important, that I will give to you. So it is also called different name I will give. Also called as also called as coordinated turn. Okay, also called as level turn, also called as banked turn. These are the different names. Okay, what is the condition for this? I will draw the diagram so it will be more clear. Okay, so in short, I'm like explaining the theory because it's not a semester lectures, it's a competition point of view. So in points I'm writing, in short definition I'm giving, but derivation I will give in detail, don't worry. Okay, what is the condition for the coordinated turn or level turn? Because turning, again it will be in second condition is what turning is what in vertical plane, one is what horizontal plane. So what I am going to explain here, it is on horizontal plane. Okay, so here condition is what? Condition is there is no change in altitude. Okay, no change in altitude. This is the one condition during the turning. Okay, there is no change in altitude during the turning. That's the reason it is called level turn also. So what is the mean of the types? So types, if you check types of turning, basically two types: turning on horizontal, second is turning on vertical plane. So on horizontal plane, that will be called as a level turn. This is called level turn or coordinated turn. Then what is the mean of vertical plane? In vertical plane also turning will have, but that will be called as a pull up and pull down. That is on vertical plane. So that is the secondary point of things that will be discussed later. Here first we have to focus on turning on horizontal plane. This is very important. In fact, vertical plane turning also very important. That is vertical plane turning, better will say pull up pull down, because it's a lengthy name, turning on vertical plane. So for that reason it is given as pull up pull down. Okay, fine. So what is our focus? Our focus is what? Turning on horizontal plane. Fine. Now, so we'll have, and what is the condition for? Definitely, if it is on vertical plane, so what is the condition for this? Okay, that should be very clear. It is very important. Okay, What is the condition for this? Condition is what? Altitude is not constant. Okay. And what is for this? What is the condition for this? As I mentioned in previous slide also, condition is what? Altitude is constant. See here I have mentioned. Check. So it should be very clear. Okay. Two types of turning we have. Turning on horizontal plane, that will be called as a coordinated turn, or it is called as a level turn, or it is called as a bank turn. But turning on vertical plane, that we have two types. One is called pull up, another is called pull down. So that will be covered, but in last. Okay. Fine. So first now we are going to check, this is the horizontal turn. Horizontal turning. Okay. So this horizontal turning, in single word it will be like a turning flight, because whenever vertical turn will come, that word will be pull up or pull down. So once pull up or pull down will come, immediately you have to understand it is vertical turning. Fine. Now, so that turning flight, we have two case. Okay, that case one, first it is going straight. So I will show another different diagram. Two diagram I will show, so it will be more clear to see. Now this is the aircraft. This is the front view. This is the front view of the aircraft. Okay. Okay. This is the aircraft. No? Nose wheel you can say. Okay. This is the simple aircraft. It is called front view. Huh? Fine. So definitely, if it is the front view, so I will must write here, so I can show the forces also. Okay. So this is what front view. So here, what are the forces? Forces I can draw that properly, so it will be more clear to you. Oh, oh. This is what weight, and this is what, it should be very straight line. I'm not in good in drawing, so it is lift. Okay, lift and weight will be like this. Okay, this is the first case. Now what is the second case? When aircraft is what? Turned towards left or towards right. Huh? Okay, so this turning you may get in directional flight, directional stability whenever I will teach. Okay, so that time turning also will come. I mean turning towards right or turning towards left. So this is the one. So it's even not feeling well, so how you can feel? Okay. Now this is the weight, this is the weight. Fine. Now this aircraft is what going to turn. If it is going to turn, so the same aircraft diagram if I will draw, so diagram will be like this only. Check properly. Okay, as I told you, I am not good in drawing, but I will try my best to draw properly. That aircraft is not banked actually. Will have a banking angle. Okay, that aircraft is what? Banked. Banking angle, na? That turning in turning flight also called uh, banked turn, right? So it is banked from the vertical. So again, I will draw the force, all forces here, so it will be more clearer to you. So check Obviously weight will be in downward direction, there is no doubt about it, because it is the gravitational force. Basically weight is what? Gravitational force. So due to gravity it will be always perpendicular down, W. Now I will take one vertical line here. Check properly. This is the vertical line. Okay. And like from the previous diagram, if you check, this was lift. Yes or no? See, this was lift. Okay. So from the vertical, this lift force is what? Making angle phi. What is the angle? Phi. So obviously, if it is phi, then this component will be what? This component will be L cos phi, and this component will be L sin phi. Agree? At the same time, one more force will come. It is very clear. It should be very clear. Okay. One more force will come, and that force will be horizontal, because the vertical force will be balanced. So horizontal force should also be balanced. This force will be called mb square by r. Yes or no? This force will be mb square by r. All right. Now this is the one diagram. Like this is the before turning, or before turning or banking. This is after turning or banking. You just recall your school time. Suppose you are going to your school, and by cycle, okay, and there by road you are going, and road is what, like suddenly somewhere it is turned towards left or right. So if you, definitely road is what turns, so you also have to turn by your bicycle, you have to turn, right? So when you will turn, sudden turn will come, then turning is what? Turning towards left or right, that is one thing. Okay. But at the same time, angle from the vertical plane, your cycle will bank. Okay, will bank. I mean, from vertical plane it will tilt, better to say tilt. Now, so if you are tilting your cycle during the turning, then only it is the possible turning case, otherwise you may not. Okay, hope you understood. Just recall it, because if you are turning towards left or right, that time your cycle should tilt from the vertical plane. Okay, it's like, okay, see, this is the vertical plane, and here you are going to, like, somewhere you are going. So your cycle, if you are going to tilt, turn in suppose right sides, your cycle should, you are here, okay, with cycle. So from the vertical plane your cycle should tilt, and that tilting is called phi, which is nothing but bank angle. It is in 12th standard physics, it was called banking. Hope you understood this. If you are turning this side, so your cycle will, from the vertical plane, it will bank by phi angle. So like, turning and banking is the process, I mean, at the same time process. If turning is there, then definitely banking is there. Without banking, turning is not possible. That's the reason it is called banked turn. It is called banked turn. Hope you understood this. Now you have to balance. Okay, huh? What is this force? Obviously weight will be balanced by the L lift component, which is nothing but L cos phi. This is L cos phi. Okay, not gamma, sorry, L cos phi. and obviously lift component, horizontal component will be L sine phi. So this will be called what? This is the force. If you remember, in like circular motion, there was force, centrifugal and centripetal force. So towards the center and away from the center. If you are turning, if you are turning this side, so definitely center will be this side. So this force is what going away from the center. What is this force? It was mv square by r, called centripetal force. Yes or no? mv square by r. So that force balancing will be in two direction. Number one, vertical direction. Number two, horizontal direction. Based on this, we have different type of the turning, or different type of wording we are using. What is that? Check. Now you understood. Okay, so I will draw the free body diagram only. This is the free body diagram. See, this is the one case when a lift is what in upward direction, and when weight was downward direction without turning. But if it is turning, okay, so lift will be here, weight will be here, and turning with phi. So this component will be L cos phi. This component will be L sin phi. To balance this, circular force will have mv square by r. Yes or no? mv square by r. So now case 1. If mv square by r is equal to L sin phi, then this is called coordinated turn. Case 2. If mv square by r L sin phi, then it is called side slip. Obviously, if this force will be more, so it will have a side slip. I mean that aircraft will slip towards the L sin phi force. Case 3. If mv square by r greater than L sin phi, then it is called cascading. This is very important. Okay, this is very important. So this is what, this is the force, horizontal force, and this is L sin phi is also horizontal force. So if you compare it, okay, if you compare, so this force is what going away from the center. So this is, you can say, circular, in circular motion you have seen this force. Okay, if you resolve the force horizontally, so L sin phi is equal to what? mv square by r. What is the mv square by force? Mv square by 4 r, that is the force, centrifugal force and centripetal, because that meaning, I mean formula will be same for both centrifugal and centripetal, only the difference is what, one is towards the center and one is away from the center. That is the one thing. Now, so m is mass, v is the velocity, r is the radius of curvature. What is the r? I will give terminology for all. R is the radius. Okay, r is the radius. Now, and I will draw one more diagram so it will be more clear to you. Don't bother about it. So if mv square by r is equal to L sin phi, then only it is balanced force. And if it is balanced force, then it is called as a coordinated turn. Then what it is called? Coordinated turn. But if mv square by r less than L sin phi, means this side force is what more. If this side force is what more, then this body means what? This is what, aircraft. So this aircraft will have a side slip towards the higher force. Second, mv square by r greater than L sin phi, then it will be called skidding. It will be going away from the center. So that is called skidding. Side slip means towards the center. Skidding means away from the center. Hope you understood this, right? This is the three cases, different cases that you must know. Anyway, now we'll draw the another diagram. Like this is the what I have told you. This diagram is what front view. Now we'll try to understand this by top view. So in top view, how it will look like. See, in top view, you check. This is the aircraft. This is the top view. Okay, this is the aircraft. Fine. This is the top view. Now this aircraft is what going to turn like this. It is going to turn. Got my point? This was the front view. Okay. Now this is the top view. So I told you if it is going to turn this side. Okay, this is the right side. Nah? Right side. Right side. If it is going to turn right side, so banking angle will be what? I explained here. See, banking angle phi will be this side. So if it is going to turn right side, so banking angle phi will get here. See, this is the phi. And if it is going to left side, turning is what going to happen left side. So that time phi angle you may get this side. And this is what? Vertical plane, VP, vertical plane. All right. Anyway, so this is the top view. So in this top view, if you check, so one condition I will show you. This is the basically point O, which is nothing but origin, you can say, and that turning is what turning about the center, and this is the center point. I told you that time. This is here. Center is what this side, and I told you this mv square is what mv square by r is what away from the center. I told you, right? So your turning is what towards this side. This side aircraft is what going to turn. So obviously center point is what this side only. So that's the reason for the top view. If you check, this is the center here. It is drawn. Now we have psi. What is this psi? This psi is the turning angle. Then what is the phi? Phi is the banking angle. Remember, phi banking angle you can see only on vertical plane. Only on vertical plane you can see phi angle. On horizontal plane you cannot see. But turning angle you cannot see on vertical plane. You can see only on horizontal plane. Horizontal plane means on top view you can see. Like here, check. So psi is the turning angle, but phi and psi both will happen at the same time. Hope you understood. As I told you, I have given the example for the cycle. If you are going to turn towards left or right, so that time you have to tilt your cycle, okay, left or right. Understood? So similarly here, banking and turning, phi and psi always happens parallelly. At the same time, it will happen. Hope you understood. But phi you can see on vertical plane, on it will be made by vertical plane, and psi will be the turning angle, it will be made by the horizontal plane. I mean on the horizontal, on top view you can see the psi, and phi you can see on the front view. Is that clear to you? So what is this force? It is explained because horizontal top view you can see the horizontal force. So this side what is the force? This is the L sin phi, and what is this force? mv square by r. What is m? Mass of aircraft. Yes or no? And v is the velocity. is, and R is the radius. You say radius of turning. You can call it radius of turning. Okay. Now, so where we are interested? For what kind of turning we are interested? We are interested only on this case 3, on coordinated turning, because we are going to study coordinated turn. That coordinated turn only, it is said turning flight. See, coordinated turn, no? Turning flight, level turn or bank turn is what? Coordinated turn. So our focus is what? On coordinated turn. What is the coordinated turn? When this mv square is equal to L sine phi. All right. So now, if you are resolving the horizontal force, so what you will have? Mv square by R is equal to L sine phi, equation 1. Vertical force, check. What is the vertical force? Vertical force is L cos phi is equal to W. This is equation number 2, right? Now, we can write one very important, because in GATE they had asked, so it should be very clear. Load factor in turning flight. What is that? What is load factor? L is equal to lift by weight. No? Lift by weight. Yes or no? Right? What is the lift by weight? If you check from the equation 2, lift by weight, from here what you will get? Lift by weight. Lift by weight you will get 1 upon cos phi. What is 1 upon cos phi? It is sec phi. Yes or no? 1 upon cos phi is what? It is sec phi. It is clear? So, I can say load factor for the turning flight 1 upon cos phi, which is nothing but sec phi. What is the value of cos phi? It is 0 to 1. Yes or no? 0 to 1. Definitely phi will not be 0. That is not possible, because it is going to bank. So it will have a one angle, particular, I mean, phi will have some angle. Okay. So some angle, it means cos phi will have a value between 0 to 1. So it is just reverse of the sec phi. So what is the mean of it? Means whatever the value you may get for the sec phi, you may have a greater than 1. Understood or not? Because cos 0 is 1 exactly. But 0 is not possible, right? Because it is going to bank. So cos 0 is 1, but 0 is not possible. I mean, phi value is 0, not possible, because it is going to bank. So if you write cos 20, 30, 40, it will be what? It will have some value less than 1. 1 divided by less than 1 will be greater than 1. So it means sec phi value is greater than 1. Means what? This is very important notes. What is the important note? Load factor for the turning flight is always greater than 1. This is very important. This is asked in GATE. Okay. This is asked in GATE. Huh? Always remember greater than 1. GATE question. Load factor in turning flight is always greater than 1. How it is, I have explained here. Okay. So this is the thing. Next, we'll continue this session. I mean, turning flight will be continued. 2 3 lectures required to complete this turning flight. So we'll see, next portion we'll see next class.